How do you know it's water? I could have had this done for you beforehand, but what could you have said if I'd have got this beaker full of something and said it's water? What could you have said to me? Yeah?
How do we know that it's water?
How do we know it's water? You sure this is water?
Yeah.
Yes? You happy that that's water?
It's fizzy.
It is fizzy because when you turn the tap on, bits of air comes through the tap, doesn't it? Bubbles, yeah? So you're happy that that's water? Yeah?
Yeah.
What's in there?
Nothing.
Fantastic. A lot think nothing, but there is air in there, yes? Yeah? We ready? That's the easy bit. I think they do that in the Bible, don't they? Change water into wine. The difficult bit is what? Greg?
Change it back again.
Changing it back again, good lad.
Would that water be drinkable now? Still?
Pardon?
Would that water still be drinkable?
I shouldn't like to drink it. You shouldn't drink, even if I took some water out of this tap, why shouldn't I drink it?
Because it's just like when you turn into wine and turn back and might have a taste.
But this is just from the tap. This is the original water. Because in a house, you've got to be careful where you take water from. You shouldn't take water from a hot tap, because that's from a tank in the roof. And you can have dead mice in there. When you go to places, it says drink it. Often it'll label it now with all the health and safety. It'll say drinking water. The second one is the chemical. What colour's that?
Yellowy.
What colour shade?
Gold.
Goldy, yellowy, yeah? Look at the shade. It's turned blue. If you watch it, what's happening? Pardon? It's turning back again, isn't it? Now, do you think teaching's an easy job? Do you think teaching have an easy time?
No.
You don't? It's not just a 9-to-5 job with all these holidays then? No?
You get an easy job if they know what they're doing.
You get an easy job if you know what you're doing. Now, My wife, she normally has my tea ready at 5 o'clock on the dot. 5 o'clock. But if the head calls a meeting and I don't get home till 6, what do you think she's going to say?
Why weren't you back at 5?
Well, yes. And a wank. Can you see that ball bit there? Can you see it?
Yeah.
That's what it is with a frying pan. Because my dinner's spoiled. So I got wise to this. And I said, here you are, my love. Some white roses. And I still got hit with a frying pan. Because she says, you know, I don't like white roses. I like pink. Not to worry. I should give them a water. So I then got my tea, but I had to eat it very quickly. I'm going to put these over here, and you're going to tell me why I had to eat my tea quickly. Yes, sir.
Because it'll fade away.
Keep your eye on it, yes? What's the next experiment then? Yeah?
Magic flowers. Collapsing bottle.
If something collapses, what does it mean?
Falls.
It caves in, doesn't it? Anything happening?
It's
What's that word?
it's collapsing.
It is collapsing, isn't it? Why do they have to eat my tea quickly?
Because the flowers are fading.
They are fading. Do you think they need some more water? We're going to put in now. What's happening? It is collapsing, isn't it?
Is the reason why it's happening because the liquid's absorbing all the air in the bottle? So no more air can get in because you seal the top and that way.
So, if the air in there is being taken out, what's happening? What's pushing from the outside?
Water.
Fantastic. What's your name?
Loss.
Fantastic, Ross. The liquid in there is in fact removing the gas from inside the bottle. So what's happening to the pressure inside? What makes pressure, gas or liquid?
Gas.
So, if that gas is dissolving in that liquid, is there much gas in there to make pressure inside?
No.
So what's happening to the pressure inside, Ross?
It's going into the liquid.
So is the pressure inside getting more or less?
Less.
But the pressure outside is still the same. And that's what's caving it in. In fact, they are virtually touching now. In fact, I could take that to my wife, couldn't I? Because there's nobody else on our street got an ornament like that. I can see a few bubbles in there. Now, when you see bubbles in a liquid, what's normally happening to it?
There's air in it.
There could be air in it, but all the air's gone, but there's still a few bubbles. If you, when you get up in the morning, think probably first thing you do, where do you see bubbles? If you see bubbles in a liquid, what does it normally tell you that that liquid's doing?
It's, is it releasing air?
Go on, it's what? When you make your drink in the morning, what do?
You like, you turn on the tap. So
Yeah,
it's,
and you fill the kettle, yeah? And what do you do to the kettle?
boil it.
So, what happens when it's boiling? What do you see in the liquid?
Turn into steam.
You see bubbles. So, in fact, do you know what temperature water boils at under normal atmospheric pressure? How many degrees centigrade? It is indeed, Ross. Now, is it 100 degrees in this room now?
No.
Nowhere near, is it? Because the temperature of water that you can just bear your hands in is about 50 degrees. So that liquid in there was boiling at about 30 degrees. And the reason is the pressure in there was, Ross, greater or less?
Less.
Less. So if you can make the pressure less on a liquid, it boils at a lower temperature. What happens to air? What people that climb Everest, what do they have to do?
Take oxygen tanks.
Yes. Because the air is what? They often say the air is
Thinner.
thinner, yes. So do you think there's as much pressure there? No. So, if you're making a cup of tea, water normally boils at 100. What do you think on the top of Everest? If the pressure's less?
100,000.
Will it boil at a temperature? Think of that. If the pressure's less, will it boil at a temperature greater than 100 or less, do you think?
Less.
Less. In fact, it'll boil at about 40 or 50. So that's why you can't make a nice cup of Yorkshire tea on the top of Everest. Because even when the water's boiling, it's not really hot. What's the next one? Yeah, outing experiment. Now, you'll get a smell with this one. It'll be a smell of wet nappies. But it won't do you any harm. Not to worry.
That's part of the fun of being in a science lab. Yeah.
If it's chemistry, it's not chemistry if it doesn't smell. Now, I would ask you again what's going in there. They show it's water because get it out the tap, yeah. It's taking a while because we're on the face floor and the pressure isn't as high up here as it is below. Just the same as when you go. Good job, we got up at Everest, we won't get any water, will we? Now, apologise for the smell, the door's open, so I say it won't do you any. It'll clear your nose. In fact, you won't remember this, but in the old days you used to have little bottles, little brown bottles of things called smelling salts. So if anybody fainted on the street, we used to get out the handbag, these little brown bottles, and put it under the nose, and it soon revived them.
Have you explained what's happened to the flame?
What's happened to it?
It's gone invisible.
It's gone invisible, it has indeed, because I have closed. When this is closed, yeah, is there much air getting in there? There's not much air getting in there, yes?
Yes.
And the gas isn't burning fully. Does anybody know what the gas is? What gas the gas is that we use now? What it's called?
Carbon dioxide.
No, because that doesn't burn. It's methane, essentially, which is carbon and 4 hydrogens. That's the gas that's in your cooker at home. Now, if this burns fully, yeah, when things burn, what gas in the air do they burn with?
Oxygen.
Oxygen. So, when the hydrogen in the methane joins with oxygen, it makes H2O. Do you know what that is? That's the formula for
Water.
good lad. It makes water. And the carbon, if there's plenty of oxygen, it makes carbon dioxide. If there's not enough oxygen, it'll only make carbon. Go on.
Oh, no, I don't know.
Good lad. Carbon monoxide, which is CO, which is poisonous. It's lethal, that is. And it's so lethal because you can't smell it or see it. And if there's not enough oxygen still, you get left with carbon. If there's not much oxygen there at all, you're left with little bits of carbon. And carbon is like coke and coal. Have any of you seen the old steam trains when they put coal, or any of you seen a coal fire? What colour does the coal glow when it gets hot?
White it goes.
Orangey, that colour, and that's why that's that colour. Because the air hole at the bottom is closed, which means a lot or not much air is getting in. But Ross, if that's closed, can air get in there?
Yeah,
No. No. So there's not much air there, there's not enough air to burn the carbon into carbon dioxide. So what that red colour is are the little particles of carbon glowing, like when you put coal on a fire. If I open that hole, there'll be more oxygen getting in, and it's burning to carbon dioxide. And that's a colourless gas, that's why you can't see it. Now, have you got the smell yet?
No.
No? I have. Think that's boiling? Think that's boiling?
Yeah.
How do you know?
It's bubbling.
Because it's bubbling, yeah?
You can see smoke coming out the top.
You can see smoke coming out the top, can't you?
You can't see.
Yeah, I've got to be quick here. What I've got to try and do is to push this water up there. Can you see why it's called a fountain?
Yes. What is that?
You think it'll fill it? Not many people can squeeze glass, can they? What can you see in there? What does bubbles mean, Ross?
I'm grey.
Pardon?
I'm grey, but that's
You're Greg. That's Ross. Greg.
it means it's boiling.
It does mean it's boiling, yeah? You think it's 100 degrees centigrade? How do you know?
Because you can hold it.
I can hold it, yes. You can see it boiling, can't you? Yeah? And it's only about, what? A bit cold today, about 20 degrees, isn't it? Now, I don't think any more's going in now. Now, experiment to do before you do so. Is it Lucy? Yeah? Wood for fire. Now, this is why I've got you sitting back. You have to be careful. That's what happened to that eyebrow. She'll get rid of this. Say something here. Don't try this at home. Now, I think I've lost this back a little bit. Keep them out of the way a bit. Now, again, the bubbles are slow at coming because the pressure up here isn't as great as it should be. Sometimes a bubble bursts, and that's when you don't know where the flame's all over the place. Can you feel the heat yet? Now, let you like to do an experiment. Can't let you do that. Now, have any of you heard of chromatography? Have you heard of, anybody heard of chromatography? Anybody? No? This. Now, you not come across that?
No.
It's from Greek and it essentially means colour writing. Colour writing. Now, I've got some bits of paper here. You can take, it's probably better if you take a darkish colour. I put a dot. I thought, do you work in centimetres now in school or inches? Centimetres? Centimetres. How many centimetres is that about?
2.
About 2.5, yeah? 2.5 centimetres to an inch. So if you put a dot on your paper about that far up, there are some racks over there, so 2 of you can put your 2 in one of those racks. Now, you want no more water. You'll not drop these, will you? Right, don't put any more water in than that, because you want the level of the water to be below that dot, otherwise it'll just wash it out. Then you will put the paper in the tube so that the bottom there is just in the water, and I want you to watch what happens to the dot. Do you think I can trust you to get a tube?
Yeah.
Don't run, don't rush about. So when you turn the taps on, turn it on very slowly, because if you turn it quickly to start with, it can gush out. You don't need goggles on for this, but you will for the experiment you're doing this. You probably won't, already had enough now, haven't you? You probably don't want to do an experiment this afternoon. Do you? No? Yeah? So, if you put it about that much water in, and I'll give you a bit of paper with a mark on, you stand it in the test tube racks over there and drop the paper in so that the bottom is just in the water. Okay? So if you want to help yourself to one of those,